Recording in progress.
Hi students, in the last lecture I have discussed problems based on image velocity. Let us now continue. So question number 6 and 7 I have discussed in the last lecture, right? See the next one. A plane mirror is in YZ plane facing positive x-axis. Its velocity is 3i cap plus 4j cap plus 5k cap meter per second. A person is having velocity minus 4i cap plus 6j cap minus 3k cap in front of the mirror. Find the image velocity of the person with respect to mirror and with respect to ground. So given velocities of mirror and object, so we have to calculate image velocity with respect to mirror and with respect to ground. Let us see how to start. Right, first note down the given data. It is velocity of the mirror. Given mirror is in YZ plane. It is facing x-axis, positive x-axis. So velocity of mirror, that is given as 3i cap plus 4j cap plus 5k cap meter per second, and velocity of the person, or you can say velocity of object, because the person is now object, is velocity minus 4i cap plus 6j cap minus 3k cap meter per second. So we have to find velocity of image with respect to ground, velocity of image with respect to mirror. So this is the given date. Let us see how to start. So first condition, mirror is placed in YZ plane facing positive x-axis. That means in this 3i cap, this velocity is now normal to plane of mirror, and 4j cap, 5k cap, these two are parallel to plane of the mirror. Let us see carefully. In the last lecture, we have discussed that if this is a mirror and if this is object, if mirror moves parallel to itself, see for this object image will be at same distance behind the mirror, right? So key point while solving image velocity, distance of object from the mirror, distance of image from the mirror are equal. So if this is object at the same distance, we're having image. Okay. Now, if mirror moves parallel to itself, maybe like this or maybe like this. If mirror moves parallel to itself, you can see image does not move, because even though mirror is moving parallel to itself, object is now at same location. Therefore, image will be at same distance in front of the mirror, right? That means conclusion is that whenever mirror moves parallel to itself, image does not move. Means image velocity will be zero. Okay. That means we no need to consider 4j cap and 5k cap. Okay. So what we can do here. So in the last lecture, we have discussed that if mirror has velocity normal to its plane, then image velocity will be twice that of the mirror velocity, right? So it is now 3I cap. So because of that, only because of motion of mirror, image velocity will be image velocity will be 6I cap. I am repeating, only because of motion of mirror, because of this component, image velocity will be 6I cap. Okay. Now coming to here, object has a velocity component normal to mirror. You can see minus a 4I cap means object has velocity normal to mirror. It is towards mirror. And because of this component, image velocity will be negative of this velocity. That means it is minus 4I cap. So it becomes a plus 4I cap, right? So this is the point which we have discussed in the last lecture. If only person moves normal to mirror, image velocity will be negative of velocity of object. So I am focusing only this component. This is normal to plane of the mirror. So image velocity negative of this. So it is plus 4I cap. So these two are because of motion of the mirror 3I cap and this is minus 4I cap. Next, these two are not required, right? Now coming to remaining two components. If object moves parallel to mirror, if object moves parallel to mirror, image also moves with the same velocity. That means for image, velocity along y-axis 6j cap and this is minus 3k cap. Okay. So if object moves parallel to mirror, image also having same velocity. That's why 6j cap and minus 3k cap. So finally answer is 6 plus 4, 10. 10 I cap plus 6j cap minus 3k cap meter per second. Okay. So this is one way of solving the problem. Let us now solve same question in a different way. And here we have to calculate. See, this is the velocity of image in ground frame with respect to ground. Okay. Let us do one thing. Now we have to calculate velocity of image with respect to mirror. Velocity of image with respect to mirror. This is what we have to calculate. So one is this I can write it as velocity of image with respect to ground minus velocity of mirror in ground frame, right? Already we got velocity of image with respect to ground, right? Then see what we get. This is 10I cap plus 6j cap minus 3k cap minus velocity of mirror 3I cap plus 4j cap plus 5k cap. Okay, let us see what is the answer. 10 minus 3 is 7. 7I cap 6 minus 4. It is a 2. 2j cap minus 3 minus 5. It is minus 8 k cap. Okay, right. Now let us do one thing. Calculate these two things in a different way. That means here first we got velocity of image with respect to ground. Then we made calculation for velocity of image with respect to mirror. Let us do the same thing in method 2. Let us calculate first velocity of image with respect to mirror. Okay. First we calculate velocity of image with respect to mirror. From this we get velocity of image in ground frame. I am repeating. So here first we made calculation for velocity of image with respect to ground. From that we are getting velocity of image with respect to mirror. Now what I am saying is in this method, first we calculate velocity of image with respect to mirror. Then we calculate velocity of image in ground frame. Okay. Now see carefully. First I will calculate velocity of object with respect to mirror. I am calculating velocity of object with respect to mirror. Velocity of object with respect to mirror. Velocity of object minus velocity of mirror. See values. Velocity of object minus 4 minus 3. It is minus 7. Right? Next 6 minus 4. 6 minus 4. It is a 2. It is a 2 j cap. Next minus 3 minus 5. It is minus 8. Minus 8 k cap meter per second. This is velocity of object with respect to mirror. Okay. Now coming to here, velocity of image with respect to mirror. See the meaning of the first one. Meaning of this one. Mirror is stationary. Then this is the velocity of object. Okay. Now see carefully. When mirror is stationary, when mirror is stationary, now for the person, velocity minus 7 I cap. This is the velocity normal to plane of the mirror, right? Then velocity of image will be negative of this one. So it is a 7 I cap. Okay. Next, if object moves parallel to mirror, image also having same velocity. Here, j cap and k cap both are parallel to mirror. That means image also having same velocity. So it is now 2 j cap minus 8 k cap. Cross check once what we got here. We got same, right? Okay. Now, after having this, we can calculate velocity of image in ground frame. Velocity of image in ground frame. That is equal to velocity of image with respect to mirror plus velocity of mirror. So these things we have discussed in relative velocity concept. Okay, velocity of image is equal to velocity of image with respect to mirror plus velocity of mirror. Now substitute values here. This is 7 I cap plus 2 j cap minus 8 k cap, right? Plus velocity of mirror. Mirror velocity is 3 I cap plus 4 j cap plus 5 k cap. Now see what we get. 7 plus 3, 10. 10 I cap Next, 2 plus 4, 6. 6j cap minus 8 plus 5 minus 3k cap. Okay. See here what we got. So we got same, right? So either we can solve in method 1. First finding velocity of image with respect to ground. Then calculating velocity of image with respect to mirror. In method 2, first we are finding velocity of object with respect to mirror. Then we calculate velocity of image with respect to mirror. Then we get velocity of image in ground frame. So I hope you got a clarity. Let us go for next problem. Let's see the question given. What are the coordinates of the image of S? What are the coordinates of the image of S formed by a plane mirror as shown in the figure? So we are given here object that is on y-axis. Distance given 4 centimeter and this mirror makes angle 45. And we have to get coordinates of the image. See carefully. First make the diagram. And we can see mirror is now. So mirror is now placed like this. This is now mirror. And object is now on y-axis. This is y and this is x. Distance of the object. This is object. Yes. Distance given as a 4 centimeter from origin. So where is image means we have to get coordinates of image. Okay. See here the only key point is distance of the object from the mirror is equal to distance of image from the mirror. Okay. Let us draw a diagram for that. So I'm drawing a normal from object to mirror to get distance of object from mirror. I'm taking a normal. Okay. This is giving us distance of object from the mirror. Now to get image at same distance behind the mirror, right? This is 90. That means now image will be, this is now image. Let us call this point as A. Condition is SA. Distance of object from mirror is equal to AI. Distance of image from the mirror. Okay. Now you can see this is origin O. Triangles OAS. Triangle OAI. They are now similar triangles, right? Because SA equal to AI. These two are equivalents. And this AO common for both. That means SO should be equal to OI. Means this also equal to 4. I am repeating. See triangle. I will write here triangle SAO. Next triangle OAI. These two are now similar. Now in that OA, common for both, right? SA is equal to AI because distance of object from mirror, distance of image from mirror, both are same, right? That means SO should be equal to, that implies SO should be equal to OI. That means now this also 4. That means coordinates are 4 comma 0. So only key point is distance of object equal to distance of image from the mirror. Okay. Let us go for next problem. See the question given. A point object is moving with a speed v as shown in the figure. The magnitude of velocity of image in mirror M1 with respect to the image in mirror M2 is. So it is simply concept of relative velocity, right? Now see what we can do. So he is asking magnitude of velocity of image in mirror M1 with respect to the image in mirror M2. Okay, let us see. So first make diagram for the given question. So diagram is given that this is M2 and this is M1, M1 and M, and this is theta. Object has velocity that is v. Okay. So velocity of image in M1 with respect to that in M2. Okay. This is what we have to calculate. Now do one thing. If you want to calculate velocity of image in mirror 2, I'm taking as V2. V2 is equal to, or let us do one thing. I'm taking this as x-axis and up as y-axis. Okay. That means here only object is moving. Object moving parallel to mirror. When object moves parallel to mirror, image velocity same as that of the object, right? Therefore, image also having same velocity. So vi cap according to our directions x and y. So v2 value vi cap. Next, we want to calculate v1 means velocity of image by mirror m1. Okay. So here what I am doing is resolve this velocity into two components. One is parallel to mirror. See, velocity is now, I'm taking for this velocity two components. For this velocity two components, one is along the mirror and one is normal to mirror. Okay, I will write here v1 is equal to velocity of image by mirror 1, that is equal to 3. See, this is the normal component. This is v, and we can see here angle is now this angle is theta. So parallel component is v cos theta. Normal component is v sin theta. Okay, it is v sin theta. I am writing here. This is v sin theta. Okay. Now, because of this parallel component, image also having same velocity. I will draw here image velocity. Image velocity is now v cos theta. So object has two components, parallel to mirror v cos theta, normal to mirror v sin theta. Because of parallel component, image having same velocity, so v cos theta. This is now normal to mirror, means it is towards mirror v sin theta. Then image will be away from mirror. It is like this. This is now v sin theta. These are the velocity components for image. I am repeating v cos theta and v sin theta. These are velocity components for image. Okay. Now I want to write these two in terms of I cap and j cap. Okay. Let us see carefully. So this is now y-axis. This is y and this is x. Then see v1 equal to, this is making with x-axis. This makes angle how much? It is a theta, right? Angle theta, because this is a parallel to mirror. That means v cos theta into cos v cos square theta. V cos square theta I cap, and for this along y-axis component v cos theta sin theta j cap. So I have taken for v cos theta two components along x-axis and along y-axis. Okay. Next, coming to v sin theta. Coming to v sin theta, we can see here what is this angle. Let me cross check one. This is theta. This is 90 minus theta. Okay. We are knowing that v cos theta, v sin theta, they are mutually perpendicular. When this is a theta, sorry, this is 90 minus theta, this will be theta. Okay. Cross check once. V cos theta making angle theta with x-axis. So with y-axis 90 minus theta. Now these two are mutually perpendicular. Okay. When this is 90 minus theta, this is theta. Okay. Now see components for that. V sin theta, V sin theta, cos theta, j cap. Next, V sin theta, V sin theta, cos theta. Wait, V sin theta. Sorry, this is again. So we are taking component now along negative x-axis, right? So this is along negative x-axis. So V sin theta into sin theta along negative x-axis. So I'm taking minus I cap. Okay. So V1. So it is equal to V cos square theta, V sin square theta. So I'm writing here V into cos square theta minus sin square theta I cap, right? Plus V cos theta sin theta, V cos theta sin theta. It is a 2V sin theta cos theta. Or this is taken as V sin 2 theta j cap. And this is also, and see this is what? V into cos 2 theta. This is cos 2 theta I cap. And this is V sin 2 theta j cap. This is now velocity of image by mirror 1. Okay. So now we have to calculate velocity of image in mirror 1 with respect to mirror 2. That is equal to V1 bar. This is now V1 bar. So it is V1 bar minus V2 bar. Okay. Then see what is it. V2 bar, Vi cap, right? That means V, I am taking V outside. Remaining is now cos 2 theta minus 1. Cos 2 theta minus 1. Okay. I cap. Cross check once. I am taking here V1 bar minus V2 bar. It is only Vi cap. Okay. So I am taking V outside. Cos 2 theta minus 1 into I cap plus, it has no J component, plus V sine 2 theta J cap. Okay. This is our final answer. Okay. If you want to simplify this, we can take like cos 2 theta. It is equal to, we are knowing that cos 2 theta is equal to, cos 2 theta is equal to, it is equal to 2 cos square theta minus 1. Okay. But we want here cos 2 theta minus 1, right? This is also taken as 1 minus 2 sine square theta. Okay. That means in the place of cos 2 theta minus 1, I can write it is minus 2 sine square theta. Means this is the answer in vector form. This is the answer in vector form. If you want modulus value V12 modulus value, then we have to take, I'm taking V outside, remaining square root of cos 2 theta minus 1 whole square plus sine 2 theta whole square. This is giving us modulus value. This is in vector form. If you want magnitude, this is magnitude. Okay. So in this, if you observe, the only difficult part is the calculation part. Okay. Just remain only calculation part taking more time, but getting velocity by M2 very simple. By M1 also very simple. Only calculation part taking more time. Okay.